All right, piecewise defined functions. Here we go. Looks a little complicated, but I'm going to break it down for you. So f of x equals, this is a big curly bracket, and there's actually three categories here. So it kind of looks like a mess, but let me explain it. So just look at the top part. F of x equals negative x plus 1 if x is between negative 1, including negative 1, and 1, but not including the positive 1. All right, so between negative 1 and 1, including the negative 1 part, this is what the graph will be. However, when x equals 1, the output is 2. All right, and we're going to look at that in the graph as well. And then lastly, we have if x is greater than 1, you'll have x squared. Now I should note, sometimes you will see this without the if statement. Sometimes you'll just see a comma there. So I've seen this written in a couple different ways. And the textbook we're using, it has the if. It literally says if, which is actually really helpful. But if you see a comma, it really just means the same type of thing. It's not something different. So this is a piecewise defined functions. It's got different pieces to them. And you will be asked different questions. So here are some of the questions you might be asked. So find f of 0. Well, okay, so this is where the x normally lives, but there's a 0 there. So now we just need to figure out what category it lives in. Does it fit in this one, or this one? Well, x being 0. Well, it's not greater than 1. It's not equal to 1. It's definitely between negative 1, including this, and 1. So it fits in this category, so we're going to apply this part, right? This piece. So just plug in 0 for x. So negative, instead of the x there's a 0, plus 1. So f of 0 equals negative 0 plus 1 is positive 1. The output is 1. That would be your answer there. So when it says find f of 0, it's 1. You just have to figure out what category it fits in. Same thing here, find f of 1. Well, which category does it fit in? Well, it's equal to 1, so this one's really easy. It just equals 2, right? And then the last one, what category does it fit in? Well, 2, f of 2, that's the x value here. It's definitely greater than 1, so you plug it into this piece, and you ignore the other two. You don't give multiple answers, there's just one answer there. You just figure out where it fits in. 2, and then squared. So that would be f of 2 equals 2 squared is 4. That's how you would do that. All right, kind of straightforward. Don't make the mistake of plugging this 0 in for each one. That wouldn't work. You got to figure out which piece it fits into. It's only going to apply, there's certain constraints for what, it depends on what the x value is. All right, and the same thing goes for the graph. So you're also often asked to graph these. So if it just says graph this piecewise function, this is what you would do. You'd start off, you'd make your little coordinate axis, get your x-axis and your y-axis. You might also see a y-axis labeled as f of x because that's the output. That makes sense that f of x is y. That's function notation. Other thing that you should do is make sure you label your axis, the scale. So 1, 2, 3, 4. I'm counting by ones here, also in the negative direction, right? And then I want to take this piece by piece and graph it. So let's just start at the top. That makes sense. We're going to graph this one, negative x plus 1, this piece. But we're only going to graph it for the x values between negative 1 and 1, including the negative 1 part. And that's going to be key, you'll see. So between negative 1 and 1, let's graph that. So this has got a y-intercept, it's linear, it's got a negative slope, y-intercept of 1. And it's, okay, it includes, remember we have an x value that is included at negative 1. So at negative 1 we've got this, it is included there. And it's a negative slope, it's going down 1 over 1, right? So this is going to come straight down this way, straight down this way, straight down this way. But at 1, at x equals 1, we don't include that. So it's going to be an open circle right there. So think back way back to Algebra 1, and you should remember the inequalities piece of that. If it doesn't have the underline, it's going to be an open circle there. So it is not including this line at that point. And also to the left of that, so x values this direction are not valid here. That's not part of the graph. So we're not going to have an arrow. That would be a big error, right? All right, so let's continue on. So this one's done. That one's graphed. Now we need to graph this part. So when x equals 1, so at x equals 1, remember we have an output of 2. So that's just a point. That's just the point 1, 2, right? 1, 2. That's that point right there. Okay. So that's that, and then the last bit, I mean that was easy, that's done. And then the last bit is, it's going to be f of x equals x squared if x is greater than 1. So we need to look at all the x values greater than 1, and from x getting bigger and bigger, we've got the graph of x squared. So the graph of x squared it's got a vertex at the origin, and it goes up like this, and then it continues up this way. It actually goes, there's actually a pattern to this simple one. It's over 1, up 1, then over 1, up 1, 3. Right? So it's going to be more like this, but it won't include that point, so there's another open circle there, and then it's going to continue up this way. So this is a parabola continuing to open up. I guess I could have drawn that a little bit better. Get the idea. What would help though is labeling this point. So this point is 2, 4, and that point is 1, 1. And it's an open circle there because it's strictly greater than 1. So the second you get any number bigger than 1 for an x value, it is the parabola x squared. All right? So the graph is just this line here with an open circle, value of 2, and it looks like that. Kind of complicated looking. So attention to detail and taking your time is really going to help you with those. We can answer a lot of different questions with that. If you go back to one of the previous videos on function notation with graphs, I investigate some of these ideas looking at a graphed piecewise function. I just didn't show you the actual this part of it explicitly. Good luck.